So, in our previous video, we discussed about the two types of rotation, from the center and from the edge. That is generally the two types. Of course, there are from the hollow, depending on the shape, size, but for SLC syllabus, we have these two types of rotations or axis of rotations for which we have to calculate moment of inertia. So for the first one, let's talk about when the axis of rotation is the center of the body. Now, let's say we have this axis of rotation. Let L be the length of the rod, a thin rod. So that means this part is half of the length. This is also the half of the length. This is rotation y dash. Now, let's take a point, let's say here, on which there is a small distance dx, a very small distance dx, which has a small mass dm. So the small moment of inertia for this is mass into the perpendicular radius, which is x square. So of course, we're in grade 12, we know that this I is equals to the integration of di going from minus L by 2 to L by 2. Now you will say, why minus L by 2? Well, because this lies on the opposite side of the axis of rotation, so we have to take negative. This becomes minus L by 2 to L by 2 dm into x square. Well, we already have dm and we have x square, so we just need dx, or the small length. So where can we get it from? Well, we have this mass per unit length. So mass per unit length of the rod is the concentrated mass m by L. So that means that the small mass dm is equals to m by L into the small distance dx. Now if we let this equation 1 and this equation 2, we can then put 2 in 1. So we have moment of inertia is equals to minus L by 2 mass L into x square into dx. We'll write the dx here. Let's just not write the into. So mass per unit length of the body is constant, so we can take that outside. And let's just integrate this x square, which is x cubed by 3. So I is equals to ml x cubed by 3 L by 2 minus L by 2. So we have, well, let's just take the 3 outside, because the 3 is also a constant, m by 3L, and this goes from L by 2, let's write in big curly bracket, L by 2 whole cube minus L by 2 whole cube. So let's just do it in our head. L by 2 whole cube, which is L cube by 8, minus L cube by 8, which is plus L cube by 8. So we'll in fact have 2L cube by 8. So 2L cube by 8 is L cube by 4. That means we will have m3L into L cube by 4. The 2 and 8 cancel. This length, this cube cancels, giving L square. Thus we have moment of inertia as m L square by 12. Now we can also derive the radius of gyration for the center of axis. Well, for the center, when the axis of rotation lies in the center. So we have I equals to ml square by 12. We also know that moment of inertia is equals to mk square. If we compare this, we have mass and mass. So that must mean k square equals to L square by 12. So that means k is equals to root under L square by 12. Well, that square cancels. 12 is just 3 into 4, which is 3 into 2 square. If we square this goes outside. So we in fact have L, we have L by 2 root 3. Now let's do it when it's at the edge. The axis of rotation is at the edge. So again, this is the axis of rotation. Now this, let's say this is the length L again, and again the small distance dx having small mass dm lies at a distance x from axis of rotation. Again we have I equals to dm into x square, small di. So that means this is integration. Well, this goes from 0 to L because it's all in one direction. 0 to L dm into x square. Now again we have mass per length, so that means dm is equals to mass per unit length into dx. Put this here, we get I equals to 0 to L ml x square dx. Thus we again have ml 3l. Let's just do it directly because we did it previously. X cube going from L to 0. So now here m3l. Well, this is L cube minus 0, which is just into L cube. This that cancels, giving square. So we have moment of inertia as ml square by 3. Now again we can derive the radius of gyration for this. Well, this I is equals to mk square. This mass are same, so that must mean k square equals to L square by 3. That must mean the radius of gyration is root L. I'll just do it directly. L by root 3. Now, in the previous one, let's just say this is K2. This K1 for the center is L by 2 root 3. So that means K1 is equals to K2 by 2. So what this entails is the radius of gyration for when axis of rotation lies in center is half of the radius of gyration for the axis of rotation that lies in the edge. So this is all for today. In the future video, we will derive some rotational dynamic equation such as angular momentum, torque, power for rotational dynamic, kinetic energy for the body in rotational motion, and etc. So thank you for now.